What is up, my homie G's? I'm sorry, yeah, that was too much. This is Miss Lloyd, and we are looking at graphs of equations today. First thing I want to talk about is point plotting method. I call it the hashtag T-chart. Pretty much if you don't know how to graph anything, this is your go-to. It basically involves plugging in some of the values into one of your variables and solving for the other so that you have an ordered pair, and then you can plot however many points you need in order to get the full picture. For my students, I tend to ask them to put it into their graphing calculator first, so then they have an idea of what numbers they need to plug in. So whenever you plug in for, say, an x, you could plug in for x or you could plug in for y. Once you plug in, you solve it to get whatever it is that the other variable is. And once you have an x and a y, you can put that on your coordinate plane. So the first thing I want to sketch, and we're going to sketch both of these on the same graph. I have my x plus y, and you can solve first if you want. Sometimes it saves a little bit of time. So I'm going to subtract my 3x. My y is kind of already by itself. It doesn't have anything multiplying with it, so I think it's a little bit easier to solve for. So when I subtract my 3x, I end up with y is equal to minus 3x plus 2. You could have 2 minus 3x. Those are the exact same thing. I'm going to have my little t-chart over here. And I know that this is a line because both of my exponents, or both of my variables, have an exponent of 1. So whenever I have a line, I don't really need to plug in a lot of numbers. Technically, you only need 2 points to make a line. I like to do 3 because I'm a bit extra, if you have not already, realized that. So first one I'm going to do, I like to start a bit easier. I'm going to plug in a -1. So y is equal to, plug in our -1. -3 times -1 gives us +3. Plus 2 will give us 5. So then now I have a point -1, 5. And I'm going to do the same thing with the 0 and the 1. I'm just going to go a little bit quicker because I feel like we should already have an idea of how to plug things into equations. So now that I've got these points, I'm going to plot them. So my first one is -1, 5. So over here, -1, up 1, 2, 3, 4, 5. The second one was 0, 2. So not going left or right, just going up. And then +1, -1. And then I've got this fancy thing on my iPad where it does a perfect line. I don't even need a ruler. It's like magic. It's witchcraft. Actually, it's not. I mean, if it really was, I wouldn't tell you. Let's just be honest. Next one, we've got y is equal to 1 minus x squared. My y is already alone. So I don't have to worry about solving anything for this one. For my students, because it has that x squared, we should know that that is going to be a parabola. And we know parabolas kind of look like these U things. So typically we like to know where the middle is and then build around that. So I would have them graph it and see where the middle is and then just do a few from either side. So looking at the graph on a graphing calculator, we can see that the middle is in 0, and I'll do that with my students in class. And we just start plugging some stuff in. I always like to do 5 when it comes to parabolas, but my laundry is going off and that just distracted me. I normally like to do 5 points when it comes to parabola. You don't really need 5, you can do 3. That's totally fine. We'll start plugging some stuff in. And now that we have these 3 points, we can get an idea, and then I'm going to tell you guys a little secret, a little bit easier way to graph these. So one of the first points was -1, 0. We also have 0, +1, and 1, 0. So then something special about parabolas is there's this like 1, 3, 5 rule. So the first one, you go down 1 over 1 because we had a negative in front of our x squared. Then you go down 3 over 1. And then down 5 over 1. I don't have room for the 5, so I'm just going to do these. And then it is symmetric, so what you do on one side, it happens on the other side as well. I really like that because then I only do half the graph, and then I just mirror it over. I can be a little lazy, and it's okay. And so if you were to plug in the negative 2 into the equation, you'd have 1 minus 2 squared is 4. And so 1 minus 4 would give you negative 3, which is the point that we have here. Negative 2, negative 3, and positive 2, negative 3. So yeah, goes with the 1, 3, 5 rule. Next bit, so I did just talk about symmetry. So whenever something is symmetric, if you cut it in half, the two halves mirror each other. They're the same on either side. And you can split it in half multiple ways. So you can split it in half with the x-axis, with the y-axis, or it can also be split diagonally. And it doesn't have to be exactly x-axis or y-axis. Those are a little bit special. You can test for those in different ways. I personally am a visual learner, and so I like to just look at it. And if I can see where I could cut it in half and then the sides would all meet up, then I know it's symmetric. If I don't see that, then I know it's not. I don't necessarily do it the algebra way, but I'll show you both. So graphical, again, if there's anywhere you could fold the graph and then all of the two halves would meet up with the other halves, like they would meet up with themselves, then you know it's symmetric. That's my test for that. There was like one that was like really complicated in the book, and I was like, I'm gonna not do that. Algebraically, if you replace the y with a negative y and you end up with the same equation, then you know that it's symmetric. That one would be symmetric with the x-axis. If you replace the x with negative x and it gives you the same equation, then it's symmetric with the y-axis specifically. And replacing the x comma y, so replacing the x with negative x and the y with negative y, if that gives you the same equation, then it's symmetric as well. Those I think are a bit more complicated. I personally think it's easier just to look at it. And then one other thing that I kind of forgot, intercepts. That's where you're crossing one of the axes. So it could be the x or the y-axis. The x-intercept crosses the x-axis, y-intercept the y-axis. I like to think of it as like if you watch American football, whenever you have an interception at the 5-yard line, that means that's where they took the ball and it was at the 5-yard line. Like that's where they were crossing whenever they took the ball. So this is kind of what we're talking about. This is where we're touching the graph on one of the axes. It's our interception. So here we want to test each equation for symmetry with respect to both axes and the origin, and then sketch those graphs. I'm going to do A, and then we're going to do B in my class with my kiddos, with my bebés. So the first thing I'm going to do is make a little T-chart. I have the x squared, so I know it's going to be a parabola. And whenever we look at the intersection, it's going to be at 0. So I'm going to use -1, 0, and +1. I'm going to plug those in and do it a little bit quicker. So then I'm going to graph these points. We've got -1, 1, 2, 3. We've got 0, -4. And 1, -3. And this one I can use the 1, 3, 5 rule. I've got just a nothing in front of my x squared, so a secret 1. So I can go up 3 and over. And 1, 2, 3, 4, 5 and over. That is one of the ugliest parabolas I have ever seen. It kind of looks like a sweet potato. And parabolas don't look like sweet potatoes, but that looks like a sweet potato. Yeah, I don't know. All right, so I also want to look at the intercepts. I'm going to talk about that a little bit. So here we can see the x-intercepts there. And they are at -2, 0, and +2, 0. And we also have a y-intercept, which is actually our vertex, which I'll go into more detail with my students in a later chapter. And that one is at 0, -4. Again, I'm going to do that other one with my kiddos, my babies. We're going to move on to circles. So standard form of our circles, this is the formula for it. This is something my kids get on formula sheets. Although I personally think that they tend to not need it. They end up memorizing this without the formula sheet, but I give it to them anyway. Sometimes it just makes you feel better. It's kind of like a security blanket. So the h and the k in the situation that are with our x and y, that is the x and y of our center. So notice I do have an x minus h and a y minus k, but in my center it's a positive h and a positive k. So it's always kind of the opposite signs than what you see inside the parentheses here. And then this is equal to my radius squared. So anytime we're trying to find the radius, we do want to take the square root of whatever all of this is equal to. So for this first one, they want us to write the standard form of the equation of the circle with its center at 5, 4 and a radius of 7. So 5, 4, they've told me my h and my k. And of course, radius 7, that's our r. So all I'm going to do is just plug this in. So x minus my h is 5. Close those parentheses, quantity squared. And then y minus my y value for the center is 4, quantity squared, equals 7 squared. And the last thing we just need to do is to square the 7, and that's pretty much it. That's it. That's the whole thing. It's not too crazy. Because you're like, oh my gosh, it's so hard. No, circles are really nice. I really like circles. They're very symmetric. So it makes me happy. Next one, the point 1, -2 lies on a circle. So it's like in the actual, like on the line of the circle. We could say the circumference. It's on the, like the line that goes around the circle. Whose center is at -3, -5. So, oh, look, there's my h. There's my k. And they want us to write standard form of the equation of the circle. So I have my h and k, but in order to write standard form, I also need my radius. And so they've given that to us just in a different way. So my center would be here, -3, -5. And then they told me one of the points is 1, -2. So we can pretend that's right there. And I know my radius is going to go from the center to the edge. And it doesn't matter where the edge is, like where on the edge, it's the same all the way around. Again, circles are freaking awesome. So then that means I just need to figure out this distance here. So we can use a distance formula that I used in another video. So in this case, instead of d for distance, I'm going to use r. So my radius, or that distance, we're looking at my x1, so from my center to the end. So in this case, 1 squared. Should be a minus sign because we're looking at the distance. So minus that 1. Plus, we're going to do the y values now. 5 minus the -2, so plus 2. And then simplifying. My radius ends up being 5. So then I can plug all this into my equation. We'll have x minus my h. In this case, that's -3. So minus negative gives us a plus. And y minus -5, so plus 5. Equal to my radius that we just found, quantity squared. And that is all she wrote, she being me. The next bit, and this is also the last question, I want to give my kids a bit more time to do these practices in class, so then they have their math teacher to ask their math questions too. They want us to find the center and the radius. Once we found the center and the radius, we then need to sketch it. So I know my center is with my h and k, which is with my x and y value. So here I have a -4 inside of the parentheses, which means, oops, my h is going to be a +4. I don't have any numbers with my y. There's like nothing there. There's nothing adding or subtracting. And I said nothing quite a lot, which means that my k is nothing, which you can represent with 0. And then my r, I will find using the 16. Remember that 16 is r squared. So I'm taking the square root of 16, and my radius is going to be 4. So my center is at 4, 0. So whatever's with the x goes in the x place, whatever's with the y goes in the y's place. I'm going to start graphing that. So there's my center at 4, 0. From that center, my radius is 4, so I'm going 1, 2, 3, 4 in every direction. 1, 2, 3, 4. And I don't really have enough room to go 4 in the other way, but I'm going to cheat a little bit and use my app to do this for me. So I'm going to line up 2 points, bring it out, and so this is where the other one would have been. And that's it, we're done. So there's my radius of 4 and my center at 4, 0. So if you got a kick out of this or learned something, please like and subscribe. If you know of someone who maybe needs a little bit of help in this, please feel free to share it. Spread the love.